All right, in our last video, we're going to compare data sets using standard deviation. The histograms show the lifespans of a sample light bulbs from two companies. The first shows a sample from brand A, and the second shows a sample from brand B. The red lines indicate the mean and each standard deviation from the mean. Compare the distributions of lifespans for the two light bulb brands. So in brand A, first thing I notice is it's symmetrical. So this is that normal bell curve. The mean here is about 1,200 hours. And we can see the standard deviation. This is that example we already saw, 75.5 hours. So one standard deviation away, two standard deviations away on either side. If we add that 75.5 hours or subtract, we can get some of those values. 68% of the data is within one standard deviation, 95% of the data is within two standard deviations. All right, so brand B, the first thing I notice visually is this is skewed to the right. It's not symmetrical. So that's just something to take note of. Here's our mean. The mean here is about 1,200 hours, similar to the other one, but our standard deviations are greater. If we're at 1,200 and the standard deviation gets us out into the 1,300 range, so that means our standard deviation is over 100. So over 100 in either direction. So if we're being asked to compare, well, both of them have a mean of about 1,200 hours. So that's something that's the same. But brand A has a smaller standard deviation. And because this is a sample size, standard deviation is used as an S, so smaller S is standard deviation. On the right, our standard deviation is larger, so it has a larger standard deviation. So when you have a smaller standard deviation, that will show less variability in their lifespans. That's a good thing. Less variability is a good thing. Since the light bulbs are more consistently closer to the mean in brand A, these light bulbs are more predictable in their lifespans than brand B. A larger standard deviation means there's more variability, which means there's less predictability. So that's how we compared. If we were to choose brand A or brand A might be a better choice just because the data is showing it's more consistently, the data is more consistent with that mean of 1,200. Because of the symmetrical graph versus the graph skewed to the right, we may have made a similar conclusion in a previous lesson, but now we can understand how standard deviations get us to a similar conclusion. All right, and then our last question, these are always just kind of follow-ups, or, well, let's consider something else. So it says compare brand C. Now, we don't have a histogram for brand C, but they told us that the mean is 1,250 hours and the standard deviation of 83 hours. How does that compare to brands A and B? Well, the first thing is that the mean, the average lifespan, is greater than the other two brands. And then the standard deviation of 83 hours, I would say that's between brands A and B. Brand A was around 75. Brand B, we estimated to be a little over 100 probably. But the main thing that we're able to compare right here is that brand C has a greater lifespan than the other two brands.